So, good day classmates. So, ako ang second reporter sa mga topic sa group 10. So, ako ang gikan sa proofs. So, proofs. A mathematical system consists of undefined terms, definition, and actions. So, undefined terms are the basic building blocks of a mathematical system. These are words that are accepted as starting concept of a mathematical system. Example, in Euclidean geometry, we have undefined terms such as point and line. Then, definition. A definition is a proposition constructed from undefined terms and previously accepted concept in order to create a new concept. Example, in Euclidean geometry, the following are definitions. So, may definitions, no? Two triangles are congruent if their verticals can be paired so that the corresponding sides are equal, and so are the corresponding angles. Then, two angles are supplementary if the sum of their measures is 180 degrees. Then, axioms. An axiom is a proposition accepted as true without proof within the mathematical system. Report ng James Raniagi siguro. There are many examples of axioms in mathematics. So, there is example. So, example, in Euclidean geometry, the following are axioms. So, muna yung axioms niya. Given two distinct points, there is exactly one line that contains them. Then, giving a line and a point not on the line, there is exactly the line through the point which is parallel to the line. Then, let's go to theorems. So, what is a theorem? A theorem is a proposition of form P then Q, which must be shown to be true by a sequence of logical steps that assume that P is true and use definitions, axioms, and previously proven theorems. So, lemmas and corollaries. So, what is a lemma? So, a lemma is a small theorem which is used to prove a bigger theorem. Then, a corollary is a theorem that can be proven to be a logical consequence of another theorem. So, example of that, from Euclidean geometry, if the three sides of a triangle have equal length, then its angle also have equal measure. Then, types of proof. So, dahil ka types of proof, ang direct proof ug indirect proof. So, what is a proof? A proof is a logical agreement that consists of a series of steps using propositions in such a way that the truth of the theorem is established. So, direct proof. So, P then Q. So, a direct method of attack that assumes the truth of proposition P, actions, and proven theorems so that the truth of proposition Q is obtained. So, muna ang indirect proof na yun ta. So, the method of proof by contradiction of a theorem P then Q consists of the following steps. So, muna steps niya. Number 1, assume P is true and Q is false. Number 2, show that not P is also true. Then, we have that P of P is true. But this is possible since the statement P of P is always false. There is a contradiction. So, Q cannot be false and therefore it is true. Or, show that the contrapositive not Q then not P is true. Since not Q then not P is logically equivalent to P then Q, then the theorem is proven. So, valid arguments. Deductive reasoning. The process of reaching a conclusion Q from a sequence of propositions P sub 1 to P sub 2 to P sub n. So, the proposition P sub 1 and P sub 2 to P sub n are called premises or hypotheses. The proposition Q is that logically obtained through the process is called the conclusion. So, ang atong P mo siyang hypothesis or premises, then ang Q mo na ang atong conclusion. So, rules of inference. So, number 1, law of detachment or modus ponens. So, P then Q. P, so therefore Q. Modus tollens. P then Q, then not Q, therefore not P. Then number 3, rule of addition, P, therefore P and or Q. Rule of conjunction, P, Q. Ito rule of simplification ba dahil? P and Q, therefore P. Rule of conjunction, P, Q, therefore P and Q. And number 6, rule of hypothetical syllogism. So P then Q then R, therefore P then R. Rule of disjunctive syllogism. So P or Q, not P, therefore Q. Then rule for quantified statements. So universal instantation for all variable x is an element of D or the domain P of x. So D is an element of set D, therefore P of D. So number 2, universal generalization, P of D for any D is an element of set D, therefore for all variable x is P of x. And number 3, existential instantation. So there exists variable x is an element of set D, then P of x, therefore P of D for some D is an element of D. Number 4, existential generalization. So P of D for some D is an element of set D. So therefore there exists the variable x, then P of x. Resolution proofs. Due to J. A. Robinson in 1965, a clause is a compound statement which terms separated by or, and each term is a single variable or the negation of a single variable. So example na kay P or Q, not A ni Q, class. It's a class. So if P and Q or R or not S is not a class. So hypothesis and conclusion are written as class. So only one rule. P or Q, not P or R, therefore P or R. So mathematical introduction, useful for proving statements of the form for all n there exists a Sn, where n is the set of positive integers or natural numbers. A is an infinite subset of n. Sn is a propositional function. Mathematical induction is a strong form. Suppose we want to show that for each positive integers n, the statement Sn is either true or false. So number 1, verify that S of 1 is true. So let n be an arbitrary positive integers. Let I be a positive integer such that I is less than n. Number 3, show that Si true implies that Si plus 1 is true. I.e. show Si, then Si plus 1. Number 4, then conclude that S of n is true for all positive integers n. Mathematical induction terminology. So, basic step, verify that S of 1 is true. Then, inductive step, assume Si is true. Prove Si, then Si plus 1. Conclusion, therefore, S of n is true. All positive integers n. Then, for more learnings, please click this link and thank you.